Hi, this is Mrs. Baston, and today we're going to talk about predicting products of chemical reactions. So just as a quick reminder, these were the 5 different reaction classifications that we talked about. So synthesis, again, is when elements and compounds are coming together to make one substance. Decomposition is when one substance is breaking down. Single replacement is when you have one ion switching places. Double replacement is when you have 2 ions switching places, and then a combustion reaction is anytime you have a hydrocarbon reacting with oxygen to form carbon dioxide and water. So as we go through and learn how to do this, the best way to approach these problems is to try to classify it, or at least have some idea of the classification before you get started. Now, the difference between these types of problems and the ones that we've done before is that for these, you will only be given the reactants. So for the other reaction writing that we did, you were given the reactants and the products, and you just had to translate it into the chemical formulas. For this type of practice, you will just be given the reactants. So it could be given the reactants where I actually give you the symbols and the compounds, or the elements in the compounds, or it might give you the description of the reactants. So when you do this, you first, like I said, see if you can figure out what type of reaction it is, because then that will help you better know what to do to predict the products. So we're going to go through each type of reaction and do some examples for each one so that you can see how this would work in each of those different situations. So the first type that we're going to look at is a synthesis reaction. So if you look at these two, it's pretty obvious that the only thing that can happen here is those 2 elements can combine to form a compound. So you have aluminum plus oxygen in the first reaction, sodium plus chlorine in the second reaction. So there's no way that there could be switching of anything. So the only thing that could happen is they're going to come together to make a compound. Now, when you're predicting products, the major thing you have to remember is that when you put elements together or you create new compounds on the other side of the yield sign, you're not simply sticking together whatever is on the left side. So when things cross the yield sign, you're going to reform those compounds on the product side by crisscrossing the charges when you come up with what those products are. Okay, so what that means is if I'm starting with aluminum plus oxygen, it's going to produce a compound that has aluminum and oxygen in it together. So if you think back to what we did before, aluminum was a +3, oxygen's a -2, so that means those are going to crisscross. So I'm going to get Al2O3 as my compound. So notice the difference between the product and the reactant. I didn't just take those reactants and stick them together. When you form the products, you always refer back to those charges. If these are ionic compounds, you refer back to those charges, you crisscross the charges, and then that forms the new compound. Then the last thing you're going to do here is balance the equation. So I have 2 aluminums on one side, 1 on the other, 3 oxygen on one side, 2 on the other. So if you want to stop the video for a second and work through the balancing, you can, but I'm going to go ahead and give you the balanced equation so that we can move forward with this. Okay, so this one, your final equation would be 4, 3, 2. So that would be your final chemical equation. The next one, same thing, sodium plus chlorine. The only thing that can happen there is they can come together to make a compound. But again, we're not simply going to stick them together. We're going to refer back to their charges. So sodium's a +1, chlorine's a -1. So when they come together, they make NaCl, or sodium chloride. Then you go back and balance. So I need, and I'm going to erase those charges here. You need 2 sodiums and 2 NaCl to make that balance. Okay, so that's how you would manage a synthesis reaction. So the next type are decomposition reactions. These are probably the most difficult to complete. They're the easiest to identify because you're only going to have that one reactant, so you'll know it's one of these decomposition reactions. But the difficult thing is you have to memorize these different decomposition patterns to know what the products are going to be. So the 3 possible types that we're going to look at are metal carbonates decomposing, metal hydroxides decomposing, and metal chlorates decomposing. So there's other types of decomposition reactions, but these are the ones we're going to focus on. So if it's a metal carbonate, and when we say metal carbonate, that can be any metal on the periodic table. So a metal carbonate, that's always going to decompose into a metal oxide. So whatever the metal carbonate was, That is what determines what the metal oxide is, and carbon dioxide. The second type are metal hydroxides. These can decompose into metal oxides and water. And then the third type are metal chlorates. Those decompose into metal chlorides and oxygen. So this is what these would look like. The first thing you would identify is that these are decomposition reactions. So notice on all three of these, it's a single compound. So that the only thing that can happen here again is it has to break up into elements and compounds. But to determine what those are, we have to refer back to those patterns. So for this first one, we have calcium carbonate. So this is a metal carbonate. So that means based on our pattern, it's going to decompose into a metal oxide and carbon dioxide. So the metal oxide comes from whatever that metal carbonate was. Same thing happens here. When we form these metal oxides and metal chlorides, we're going to refer to their charges, crisscross their charges, just like we did on the last type. So the first thing I have is a metal oxide. So again, this initial compound determines what your metal is. So whether it's calcium, sodium, potassium, whatever, that tells you what that metal oxide is going to be. So calcium is a +2. Oxygen is a -2. So you're going to crisscross those, and those are going to cancel out because they're the same. So I'm going to erase them. So calcium oxide, this is your metal oxide. And then your other product is CO2. Okay, then the only thing you have left to do here is balance. This one ends up already being balanced, so that one is complete. Okay, the second one is an example of a metal hydroxide. So calcium hydroxide, that's a metal hydroxide. These decompose into metal oxides and water. Again, same deal here. The metal comes from whatever that initial metal was. So this is still going to be CaO because this is the same metal oxide we used before. But this time it's producing water because it was a metal hydroxide instead of a metal carbonate. This one also ends up being balanced, so that one's complete. Last one is a metal chlorate. Okay, so any metal attached to a chlorate. This one decomposes into a metal chloride and oxygen. So again, the metal for your product comes from whatever metal was in the reactants. So calcium chloride. Calcium's a +2, chlorine's a -1. So I'm going to crisscross those down. So CaCl2 plus oxygen. And then to balance this one, we need a 3 there. Okay, so like I said, these you have to memorize those 3 patterns so that when you see a decomposition reaction, you know what the products are. So if you notice when these decompose, they don't just break apart. So they're actually producing other things, which is why we have to memorize those patterns. The third type is a single replacement reaction. So in this situation, to predict the products, you're going to switch the element that's by itself with either the positive or negative ion in the other compound. So the way you know which one to switch out is it's going to switch out with the one that's most like itself. If it's an element that forms a positive ion, it's going to take the place of the positive ion in the compound. If it's something that forms a negative ion, it's going to take the place of the negative ion. So we're going to look at that situation for both of these. So for this first one, we have copper reacting with silver nitrate. So copper we know is a metal, or it forms a positive ion or a cation. So that means it's going to take the place of the metal or the positive ion in the compound. So that tells you which of those substances is going to be left by itself in the products. So that means silver is going to be by itself, and then the copper and the nitrate are going to form a compound. Again, same deal as before. You're going to crisscross those charges on the other side, on the product side. So for this one, you would have to be told that this was copper 2. So we're going to assume this is copper 2. So copper would be a +2 charge. Nitrate, you know, is a -1 charge. So when it crisscrosses, you get CuNO3 parentheses 2. Okay, so I'm going to erase this. So you can see the copper forms copper nitrate, and then the silver comes out by itself. This one you do have to balance. So again, if you want to stop and practice the balancing, you can. If not, this is going to take a 2 in front of the silver nitrate and then a 2 in front of the silver to balance. Okay, in the second example, bromine is a nonmetal or forms a negative ion. So that means it's going to take the place of the nonmetal or negative ion in the compound. So this time it's going to knock out the second element instead of the first. So that's why you have to pay really close attention to what that first element is, because that tells you which one it's going to replace in the compound. So that means iodine is going to come out by itself. And remember, iodine is one of our diatomic elements, so it's always going to have a 2 with it. It's not just going to be I by itself. And then the sodium is going to combine with the bromine. And again, this goes second because it has that negative charge. So sodium's a +1, bromine's a -1, so +1 -1 would give us NaBr. And then to balance this one, we would need a 2 here and a 2 here. Okay, so when you're doing the single replacement, those elements can either knock out the first element or the second element, depending on what type of element it is. If it's a metal or it forms a positive ion, it's going to knock the positive ion or the metal out of the compound. If it is a non-metal or it forms a negative ion, that's the one it's going to take the place of in the compound. Okay, the next type is our double replacement reaction. So we've talked before about how this basically are the compound switching partners. So to predict the products here, we're going to switch the ions in the compounds. So whatever is combined with the first compound, so I have sodium and chlorine, it's going to switch out and switch ions with the other. The easiest way to do these is to, on the product side, whatever is first in this compound is going to go first, and then whatever's first in this compound is going to go first in the other product, okay? Because the positive ions in a compound always come first. Then all you have to do is switch the second ion. So that means now the sodium is going to combine with the NO3. Again, just like we've been doing, check the charges, crisscross. So NaNO3, that's a +1 -1. And then the silver is going to combine with the chlorine. I got my arrow kind of in the wrong place here. So the Na goes with the NO3, the silver goes with the chloride. So again, +1 -1. Okay, this particular one is already balanced, so we can leave it the way it is. I'm gonna get rid of all these. So again, all they're doing is switching partners. The chlorine is going to combine with the silver, the nitrate goes to combine with the sodium. So like I said, if you leave those first substances first and then just switch whatever the second part is, that's the easiest way to approach these. So same thing on this bottom one. So I know potassium is going to go first in the first compound. Lead's going to go first in the second one. Then the iodine is going to combine with the lead. The nitrate is going to combine with the potassium. So potassium and nitrate. So this is a +1 -1. And then lead and iodide. Here you can tell this is lead 2 from that subscript right there. So that's lead 2, iodine -1. Crisscross those. That's going to be PbI2. Okay, again, I'm going to go back and erase these before I balance it. Erase this. But again, you notice all we're doing here is they're switching partners. But on the other side, positive ions written first, negative ions written second. And to figure out what those formulas are, we're crisscrossing the charges. So this last one to balance, I need a 2 here and a 2 here. Okay, our last type are combustion reactions. These are the easiest ones to predict the products for, but they tend to be the hardest ones to balance. So for these, the way you'll recognize that this is a combustion reaction is that it's some kind of hydrocarbon reacting with oxygen. So these are 2 different examples. So this one just has C's and H's. So for these, it doesn't matter how many carbons, how many hydrogens. If it's a hydrocarbon reacting with oxygen, products are always CO2 and H2O. Okay, like I said, the hardest part about these is balancing. This is a very challenging one, so if you want to try this, go ahead and stop the video for a second and then come back. So to balance this one, you need a 2, a 19, a 12, and a 14. Okay, so like we talked about, the combustion reactions are the ones where you can have some pretty big numbers as coefficients. This second one is also a combustion reaction. So it has the CH. Sometimes you'll see this OH attached. Sometimes it'll just be a CHO compound, which this one is. It's just written a little bit different with that OH on the end. But those are still considered hydrocarbons and combustion reactions. So when that reacts with oxygen, you still get CO2 plus H2O. So it doesn't matter what that first compound is. If it has C's and H's and reacting with oxygen, your products are CO2 and H2O. Like I said on these, the biggest problem is going to be balancing. This last one isn't as bad. So you need a 3 there, 2 there, 3 there. And we'll do a lot of practice with this in class. You'll do a lab where you do some of these. So this really just takes practice to go through. But again, like I said in the beginning, the best thing to do is to try to identify the type and then follow the rules or the patterns based on what type of reaction it is.